Dr. Shraddha, you can please check at your end, maybe some connectivity issue because other participants are hearing me. Okay, so thank you. With this, I would start today's session. So today, basically, we will continue from where we left. So yesterday, like Dr. Devjani and Dr. Siva has briefed regarding what they learned yesterday. And today, again, coming on to the same matter, that was the scale and the type of scale that is a reflective versus causal formative. Because I said that we will repeat this many times because it is needed when you are going to do the validity studies, reliability studies, and the factor analysis. So in the first session, there will be two breakout rooms today. In one breakout room, we'll do the exercise on reliability. In the other breakout room, we'll do the exercise on the validity. So first, we'll understand the concept of reliability. So what is a reliability? So yes, before I start, yes, anyone from the participant, what do you understand by reliability? All of you, I guess you are well versed with this term, maybe in some other context. But what do you understand by reliability? So repeatability, Dr. Neeraj, Dr. Dhanya. Okay. So traditionally having the same results. Okay. So yes, traditionally this definition, we keep on reading and we keep on using this definition. This is the reproducibility or maybe the repeatability. But in case of scale, the concept of reliability, we define reliability somehow differently. And we'll see that in terms of the error measurement. So reliability, if you see reliability for a scale, it is basically how much error we are reducing, that we mean by reliability. And we'll see how it is different from validity. Because in case of validity also, we say that error should be less. In both the case, error should be less. Then how the reliability is different from validity, that we'll understand. So that term, which is reproducibility or repeatability, which we have seen earlier, we will not discuss that concept because again, I said that reliability of a scale, it is defined differently as we already know. So just see this video. So let me share the sound. I guess I have not shared the sound. That's why.
Taladani. Oh, watch this one go. It's nearly in our box. Oh.
Dhoni this time. My goodness.
Here comes Kohli. No, it's not. It's the skipper. It's done. Oh, my word.
Oh, and he launches the big bang.
So what is your reflection on this clip? So Dr. Samina has written the same thing. Ashish Pundir is also writing that having the same result. Dr. Vikram is writing measure what it is supposed to measure. Okay. We'll see that. And Dr. Neeraj is writing like different shots and same outcome. And yes, can you say that that style or with which he is doing that? Yes, it is the same outcome. So every time it is the 6. So we can say that he is reliable or the shots are reliable. Maybe yes, Prashant is also right. Consistency or that same repeatability, which we already know. But the process is different. The Neeraj is writing. So again, coming to the same diagram, which we learned yesterday. So right now, I want all of you to focus on this. So if you see this is again which type of measurement model we are discussing. Can someone from the participant write, or you all can type? We read 2 types of measurement model. Yes, Dr. Priyanka is writing reflective. Sana is also writing reflective. Avinash, Frederick, Satyanand, Dr. Neeraj, Parul, Shiva. So yes, you all are right. It is reflective. So how we define a reflective is, there is a y this. This y is a latent variable or a construct. We define that both these latent variable and construct are same. So we are measuring some latent variable, and these are the items. So if I focus from x1 to x2, so I have these 5 items which is measuring my construct y. Now you can see the direction of arrow. That means the change in y is determining the change in x1. That means the y is affecting these x1. And that's why we say that it is a reflective. Change in the y is getting reflected by the y. Sorry, change in the x1, x2 to x5 is getting reflected by y. So if you talk in the terms of dependent and independent variable, so which will be the dependent variable in this case? Yes? Which will be the dependent variable, x1 to x5 or y?
x1 to x5.
So x1 to x5 will be dependent or independent? So y will be dependent and x will be independent. So yes, a mixed sort of answer is coming. So if you see, y is affecting these x1, x2 and x5. So y in this case is a predictor variable. So it is the independent variable. So in this case, y is the independent and x is the dependent. And we'll see that in factor analysis, because I said yesterday that factor analysis is a little bit similar to the linear regression analysis. So in the linear regression, what is there? The predictor variable is observed. Like if I want to measure the weight of like we say that if you want to calculate weight is equal to age into 2 plus 8, let's say. So age in this case is a predictor variable of weight, but age is an observed variable. Whereas in this case, this y is an unobserved predictor. Okay. Dr. Neeraj is writing, but ma'am, ultimately we are measuring construct y by using this. That is okay. Okay, any problem with my connectivity? Okay. Is it okay now? Yes, so let me see. Dr. Neeraj is writing, so how y is independent? Okay. Why? That's the reflective model actually. Because in this reflective model, why these x1 to x5, they are being affected by y. But we are measuring x, we cannot measure y. That's why you can say that y is determining why x should be. Hence it is independent. Yes, Dr. Dhanya rightly written it, that y is determining the x1, x2, x3, x4 and x5. That's why the direction of arrow is from y to x1 to x5. It is not the other way around. I hope you will understand this better subsequently. But just remember that this y is an independent variable. It is not dependent. In case of a reflective model, it is not independent. If you are making y as a dependent, then the direction of arrow will be from x1 to y. And that happens with which type of model? Yes. Can someone write it here? Causal formative. Yes, you are right. So in case of a causal formative, the y, like in case of a socio-demographic variable, the how much income that person is earning, that is going to define its socio-demographic. And that's how the two indices are. Yesterday we read that multi-item index, and there is a construct. Okay. So yes, I'm explaining this with the example, Dr. Neeraj. Let's see the example of in case of a reflective model, maybe depression. So the item which we are measuring, if suppose you take the example of yesterday's statistical anxiety, and there was an item which was saying that, I am very afraid of mathematics. So I'm very afraid of mathematics. If this is one item, my statistical anxiety is affecting this item. It is not that. So that's why we remember, yesterday we talked about something like which came first, construct or item. Then all of you said that it is the construct which came first. So construct is there in our mind. It is there in our psychological domain. And based on that, while developing item, based on that expert review, focus group discussion, clinical observation, we have devised those items. So those items are the reflection of your construct. If the construct is getting changed, then that will affect the item. So that can we say that if I increase the number of item, or can I say that if I drop that item, your depression will go down? Can I say that? I cannot say that, because that item which I have taken, the depression is getting reflected in that item, means depression is affecting. That means a person who is not depressed, he will respond differently to that particular item. That means the amount of depression a person is having. Suppose if I'm a normal person and I love statistics, let's say, although I don't, but if I say that there's no statistical anxiety in me, and I love reading tables of this manuscript, then will you say that this item is measuring my statistical anxiety? No. Actually, my statistical anxiety is getting reflected in that item. That means since I have no anxiety, that's why my item will score probably low on that particular question. It is the vice versa. Because I have devised those items to measure something which is unobserved. We say that, agree. But you will get confused with this sentence, because till now we have been reading that whatever is not known, we are trying to measure that. And that's how we develop model, isn't it? But in this case, it is a little different from the other concept. Here, that's why to understand this measurement model concept is the crux of understanding the scale development and the overall CFA and EFA. If you have understood this well, you will be able to explain the results which you have got, or maybe whenever you will apply analysis. So this says that if I am healthy, my item will score low on that particular domain. If I say that high item means like I am having that particular bad on that construct. Okay. So that's how we explain. So, and that is variable. So let's say we are 4 or 5 people here. So if I've got no statistical anxiety, I'll score less. If somebody has got more statistical anxiety, he will get higher score on that. So that anxiety is persisting. It is not there because of that question. Are you getting my point? That anxiety is not there. See, we are, most of us are anxious for one or the other event. If we are driving and suddenly if we see that we are busy with some other thoughts and suddenly something comes. So that anxiety, it is an inherent quality. It's rather than you can say it is there in our psychological domain. All these constructs are there in our psychological domain. And yesterday we were discussing like love, maybe the prejudice, the depression, anxiety, maybe the readiness to change. Like these days you will see a lot of people are working on the health behavior. Why people are not ready to continue with the compliance? What happens, like you see most of us take medicine for, like, if the antibiotic course is for 7 days, we stop taking medicine probably after 2 to 3 days. What is there in our psychological domain that is stopping most of us to continue with the treatment? So all these things are existing. So the reason of that construct is the theoretical domain. That's why, remember, we discussed yesterday the theoretical versus a theoretical construct. Like socio-demographic variable, we cannot say it is a theoretical construct. It is a theoretical construct. If you want to measure, like, I'll give you one example. If you ask me, how is the work environment at AIMS? And then maybe if you ask this question and if you want to measure the work environment, how good it is. So you can do two things. One thing you can see, like, like there is a time-bound promotion. I'm telling you in context of faculty. So there is a time-bound promotion. There is a flexibility of work. There are 24 hours. There is a light. There is an internet connectivity. So all I have taken 4 or 5 indicators. And then I say that if it is yes, and this much score is there, then the work environment is good. And if it is not, the work environment is not good. So if I am doing like this, then which type of scale I am using, which type of item and which type of scale. So it will be a multi-item because I have selected few items and it is all directly measurable. There is no measurement of construct. But if I ask from someone, how do you perceive your work environment? So there can be a possibility that all of these indicators are good. But in spite of that, the person will feel that the work environment is not good, or maybe he will not feel motivated to work. And we see it in our everyday life that we provide everything to a person. In spite of that, he is not ready to work. Most of you will face this problem regarding getting the things done efficiently, management, the leadership. So aren't you observing this on an everyday basis? Why people don't want to work, probably? What is the factor? So these things will, so there is some theoretical construct or there is something which is lying in our psychological domain. And if you want to measure that, we have to devise this reflective scale. Okay. So this reflective scale, like I hope Dr. Neeraj, have you understood? You can only text. Okay. So this is a reflective. So that's why this y is an independent variable. The difference between y here and in linear regression, that y was that predictor variable was a known variable and it was an observed variable. Whereas in case of factor analysis, which we will see tomorrow, it is not observed. But again, it is on the same principle. So y is getting means the variation in x1, x2, x3, x4 and x5. It is y is affecting all these commonly. But again, I said yesterday that error item is unique for everyone. Okay, error item is not same. That means I am not attaching E and connecting error to all the item. What do I mean by this? That error is unique to all the items. And we will understand this tomorrow also. That means there will be some, let's say if I say that 70% of the variation in this item, let's say statistical anxiety. So if I score on a particular item and that value is probably 0.7, then I can say that 70% of this will be is getting explained by Y. But what about the 30%? So rest 30% is a error, which is a unique. And that's how we define this reliability. So basically, this reliability is a ratio of true score by observed score. And we know that observed score is more generally because observed score is true score plus error. If you get these here, so observed score is always the true score plus error. That means whatever you observe, that is always more than the true score. That's why the value of reliability is between 0 to 1. It is never more than 1. So reliability is defined as true score by observed score. Because how much this observed, like how much this observed score is near to true score, that we is defined as a reliability. So have you understood up till this point, all of you? We'll learn the various types of reliability, but have you understood regarding the error, the observed score? So this, the score which you observe, this is the observed score, because true score is not known. That's why I said the true score is not known. So that is the along with some error. So this measurement of error, it is like the reliability estimates shows this measurement of error basically. And there are various ways to measure that error. And one of the most common ways is to measure these things, the analysis of variance. It's the variance. All of you know what is a variance. So analysis of variance is a one very common method to measure this error. I'm not going to tell you the details of those statistical concepts, because the purpose of this workshop is to make you people empower in understanding the reliability and doing it. So we will learn it on JAMOVI, how to do the commands and how to interpret it. So this measurement error, so I want my measurement error to be less. So lesser the measurement error, more reliable my, so I cannot say more reliable my scale would be. I'll tell you why. Because reliability is not a measure of scale. It is the measurement of the data where I have applied the scale. So I'll tell you. So I can say that the reliability of the stool in this population is this much. Okay. So reliability is always talked in context of a population. And validity is of scale, but reliability is of data. That we'll see. So now the first is your content sampling. So what do you mean by content sampling? So content sampling is, remember yesterday we discussed like you devise a lot of item probably. So from that item pool, so on the basis of expert review, or maybe if you want to devise your own scale, but taking the literature review. So in literature, you have found out, like, let's say the example of stars, that statistical anxiety. So if I have got 3-4 scales of measuring statistical anxiety, I have picked few questions from one scale, few more questions from scale 2. So different questions I have picked from various scales. So those are the universe of items which I have, and I have picked up randomly. And then I will see whether that particular is consistent in measuring that construct or not. That is evaluated by the internal consistency of the items, and which we'll see, which we measure as a this thing, Cronbach alpha, which is the measure of internal consistency. Now the second is, the second error source would be the respondent. So what respondent, how respondent can be a source of error? So if, like I assume, if the tool is reliable, then remember all of you typed in first instance that repeatability. You said that it is reproducibility or repeatability. Like I have not shown you here, but if you like measure something, weight of a person thrice or 4 times, and if you see that it is giving you the same weight every time, then you say that it is a repeatability, reliability is good because it is giving the same result. In case of a respondent, can you do like this? Like you have administered a depression, or maybe I have given you the statistical anxiety rating scale yesterday, and I give you immediately after 5 minutes the same scale, and immediately 10 minutes after I give you the the same scale. Can I do like that? Like we do for BP. BP, what we do? We take 3 measurements. So in case of a scale, can I do like that? Like I can, because how? So yes, it's we usually we don't do that. Even if we have to do, we do it after some time, because this test, and this is the how it is observed, that you give this instrument after a month, so that with time, do you think that when the person has responded for the first time, he is having some different state of mind. And when you have administered in a second time, maybe at that time he's in a good mood. So there's no stress. So can any other factor is also affecting those items? So that is tested by the test retest reliability. So generally it is done. You administer the question. I'm not saying that it is done. I'll tell you how it is done. It is not done the way that you administer the question now, and then after a month you administer the same question to the same set of people, and then you measure the correlation coefficient. So you will see that in all these statistical analysis, we are relying on the Pearson's correlation coefficient. And I hope all of you know that this Pearson correlation coefficient is the strength of association between the two continuous variables. That's why, remember I said yesterday that ideally it should be continuous whenever we are measuring reliability, or whenever, that's why we should not have a Likert item of a 3 this thing. It should at least be minimum 5 item scale. Okay, not item means rating scale should be of 5-point Likert scale. So that should be there, because I want my ordinal item to be treated as a scale variable. Scale means as a continuous variable. That's why I want my 5-point Likert scale, or maybe 7-point, or it can be 6-point also, because yesterday one of you have asked that can it be odd or even number? Yes, it can be odd number, it can be even number, both are okay. So this is the test retest reliability, which is also known as the temporal reliability. That means with time, is the individual is persistent with his response in that particular items, which I have kept in my scale. Now coming to the third type of reliability, is the scale which I am using, if I am using that scale and if some other person is using that scale, is there is a difference across raters. So this is possible when it is when we take the interview. It is not there if it is a self-administered. In case of a self-administered, this inter-rater reliability will not happen. But if I am taking the interview, some other person is taking the interview, and then it is the across rater, and that we see by the kappa statistics, which we will not discuss in this session. So coming to the types of reliability, again, there's one more type of reliability, which is known as the split half reliability. So I have discussed this test retest reliability. We'll discuss it more in length. And split half reliability. The third type is a Cronbach, and fourth is the inter-rater, that is the kappa. So this test retest reliability. So again, I have said that this. So same people interviewed by 2 raters. Yes, same people interviewed by, like we do in case of an X-ray. Same X-ray read by 2 people. So same this thing by the 2 raters. Yes. So this test retest reliability. Yes. So can someone read this? Dr. Shraddha, can you read this? What is written? Although it's a crowded and busy slide, but I have kept it purposefully because it is as a reference slide for you people. Okay, you don't have a mic. Okay, anyone who can read this, that's okay, no problem. That's pretty okay. Anybody? Dr. Dhanya, thank you so much.
Test retest reliability. Test retest reliability refers to the extent to which individuals' response to the questionnaire items remain relatively consistent across repeated administration of the same questionnaire or alternate questionnaire forms. Pearson's R between the 2 questionnaires response can be referred to as the coefficient of stability. A larger stability coefficient indicates stronger test retest reliability, reflecting that measurement error of the questionnaire is less likely to be attributable to changes in the individual's response over time.
Okay, thank you, Dr. Dhanya. So now by reading all this, I hope you are clear now what is a test retest reliability. So yes, there is a line here. This one. What do you mean by this? Anyone? In the group? Okay. Rephrasing, modified. Re-administered. In case of a re-administration, it will be the same questionnaire. Using different Likert form. Okay. So I'll tell you, one thing can be modified, which Dr. Priyanka said. Initially, like maybe I have a translation or interview form, different questionnaires. But how come a different questionnaire you can use? Because I am saying that it is the tool of a same question. So it is, again, I have deliberately not talked about that, but there is something known as the alternate form of reliability. And this sentence is stating that. That means I said that initially you have a pool of, let's say, 100 items. Remember, while generating pool, yes, you are right, Dr. Shraddha, different items. So for measuring a construct, if the expert has given like 110 items, you have selected 110 items, but randomly with another set of experts, since you cannot administer that long question, you have decided that let's keep it like 40. So you have got a 40 set of item. Then the rest, you can again select some other 40 from the same pool, and then you can administer that. That is known as the, so that item is measuring the same construct, because that is, you have gathered those items from a very rigorous process of the expert review, and that again is an iterative one. So if you are choosing some other item from that pool, and then you will have two questionnaires, but developed by the same expert committee. And then if you administer these two, that can also be one form of reliability testing, which is known as the alternate form of reliability. Okay, although we don't do it. Why? Because we don't have that excess of that pool. But if you read the articles and the development of the tool, then you will see that they quite a time they do this alternate form of reliability to see whether their pool, which and the other questions which they have not kept and leave it deliberately, is there any consistency between those two type of questionnaire or not? So this is the retest reliability. So Dr. Neeraj is writing, it can only be done if you are sure about the internal consistency of the item to measure the construct. Yes, you can do that. You can initially do the internal consistency of all 100 items. And then we'll see that. Another type of this is the split half reliability. I'll show you that. So this content reliability. Content reliability. No, that was not content. Actually, the content sampling. It was a content sampling. Actually, reliable content term we add generally with validity. Content validity. This is our content sampling, Dr. Shraddha. Okay. So this content sampling is again from that initial pool. What item you select, that is, and that we measure by the internal consistency. That which is like measured on this Cronbach alpha or the reliability which we are doing it. So this content sampling is basically from a initial pool of item we select some 20-25 items. So that's the content sampling from the pool. And if there is a high reliability, that means we'll see that value of Cronbach alpha is like 0.8 or 0.9, then we can say that the items are internally consistent. That means scale is internally consistent. That means there is less of measurement error. Okay. Dr. Shraddha, we'll see this again when we'll do this in JAMOVI. But have you understood this content sampling? I hope you are asking content sampling, not the reliability. You can type, because since you said that there's no mic. So it is the content. Yes, Dr. Bashar, you are right. Internal consistency checked by Cronbach. That is one thing. But Dr. Shraddha, have you understood this? What is a content sampling? I cannot see a yes or no. So I'm moving ahead. Maybe if you have not understood. So Dr. Prashant is writing, no. Dr. Shraddha. Okay, so your question is now getting this thing with the validity. You are writing a construct has got 3 domain and correlation of 3 domain. No. That is a validity, and that is a different type of validity, which is a construct validity. So construct validity has a convergent validity, which you are showing it here, correlation, convergent and discriminant validity. So we never talk of construct in reliability. Okay, in reliability, we always talk of items only. We don't talk about construct. Construct is the unknown or the hidden thing. So that we talk in validity, not in reliability. So have you understood, Dr. Shraddha? And there was another no. Dr. Shamshad, can you go a little up? And I can see there was a no. Dr. Prashant, I guess he has written no. Dr. Prashant, can you unmute and say what have you not understood in this concept? Maybe you can write if you don't want to speak. Can I see? Okay. So you can again write to us if you are not, because I cannot see that message of either yes or no. So I'm moving forward. So this was the content sampling. It is not a content validity, content reliability. Remember, don't confuse content validity with content sampling. These are two different things. And in reliability, we never talk of construct. In reliability, we will always talk about these. This X1, because that is the observed. So we will see that whether they are correlated with each other or not. That's the only thing which we see in reliability. And in the output also, you will see that how we see. That means we say that if there is if X1 is measuring the Y, I mean, if X1 is getting affected by Y and X2 is also getting affected by Y, then X1 and X2 should be highly correlated. Then only we can say that all the items are measuring, means as a reflection of this Y. So this is the thing which we measure in the reliability. We see the correlation between the X1, X2, X1, X3, various items. And we say that if they are well correlated, that means they are getting affected by a common variable. Okay, that's the basis of doing a reliability studies. So this we discussed this. So yes, so this question is for you people. So can we do the same test, retest reliability for a questionnaire or a scale? So ideally, yes, please write yes and no. So practically, is it possible? Test, retest reliability. So maybe you can ask from few volunteer and then you can do. But as a process of, so you can do this, yes, okay. And again, but practically you will see that we don't do it. Once we go to a person, we ask that we don't administer the same scale, but you can do that. There's another approach to solve this problem. And how that problem is solved. So you can ask a construct with many different ways. Like for one, if you have for one item or for one construct, you can have many questions. And if all is having a, you can say a high correlation, then you can say that it is measuring it. Yes, Dr. Devjani is right that after a washout period, you can definitely ask that probably. But there is a problem of that also, because then they will try to see the initial score probably, or then they might remember something, but still that can be done to see the correlation between the two. So now let's understand this with the example that if you want to measure the anxiety and depression status of student. So I asked the following question. Again, this is a wrong question because I am asking over the last 2 weeks, were you anxious and depressed? So there should be, were you anxious? And then again, were you depressed? So if I ask this question, so one student has, so you can see that there are, these are the students who have given me the score. So this is for feeling nervous, anxious, or on edge. So 0 is not at all, 1 is several days, 2 is more than half a day, and 3 is nearly every day. So these are the 4 items. Sorry. Again, not being able to stop or control worrying, feeling down, depressed, or hopeless, and little interest or pleasure in doing things. So these are the 4 questions, and they are the response scale. So I have got these 7 respondents, and they have responded on item 1, 2, 3, and 4. I'll again show you the scale so you can see that all these questions are questions where high score will say that they were anxious and depressed, and low score will say that they were not. That means they were healthy. So now you see these 7 response. So can you say that where you will see that there is no reliability in responding? Means there is some error from the respondent side. So you can type in the chat box. R6. Agree? R6. True? Yes, R2 also. Dr. Neeraj is writing because R2 you can see on item 1 and 4 he is saying 0 and 1. And for item 2 and 3 he is saying 3. So you people are right. So if you say this, it is not possible that you on one item that is on, if you take this first person. So he R2 is saying for item number 1, he is feeling 0. So for first item, this one, feeling nervous, anxious, or on edge, not at all. And for other, like not being able to stop or worrying and feeling down, depressed, and hopeless, he is saying that he has scored 3. So this is not possible. That means that there is no internal consistency. So this also can be checked by the reliability or the Cronbach alpha. So now coming to the items and the number of items and reliability. So it is always said that if you increase the number of items, the reliability of the scale in that population will increase. So how that is there, we'll learn this. So there is a positive correlation between the number of items and the reliability. But it is not as a linear, it is a non-linear. So how it is a non-linear? Initially, there is a rapid increase of reliability if you increase the number of items from 2 to 10. Then from 11 to 30, there is a steady increase. It is not as high as you have seen in from 2 to 10. And after 30 and 40, when your item reaches 40, then there is a plateau. That means there is not much increase in the reliability. So this is the relationship between the number of items and reliability. That's why you will see most of the scales initially when they were developed, like PHQ 9 also came after some initial many revisions. And then from PHQ 9, there is a PHQ 4 also, which is the patient health questionnaire. So although whenever the scale was developed, if you have more number of items, then the reliability or the internal consistency, because one particular concept or the component you are asking through 4, 5, 6 questions. So if you are getting the same response, then you can say that, okay, there was an internal consistency. So now some basics again of this reliability, that this reliability is very important when we want to measure the latent variable, because they are not directly observed, but they are the inferred from the other variable. And that's how I said that Y, which is a predictor variable, the latent variable, this is an unobserved or not observed. And it is important to maintain this reliability because it indicates the consistency of the survey result. and it is measured by the Cronbach alpha, which is most commonly used for the Likert type of questions. So this, if you see this internal consistency or reliability, it measures the extent to which all the item, if you remember that item Y1 to Y5, all the items in that questionnaire are highly interrelated. And if they are highly interrelated, that shows indirectly that they are getting affected by the same construct or same latent variable. So it shows that there is a consistency in the measurement of the same construct or concept, and it is estimated using the coefficient of alpha, which is also known as the Cronbach's alpha. The value of this Cronbach alpha ranges from 0 to 1, and if the value of Cronbach alpha is 0, we say that there is no internal consistency. If the value of Cronbach alpha is 1, we say that there is a perfect internal consistency. So there should be at least 0.7 Cronbach alpha to indicate that the scale in that population has got a adequate internal consistency. So some basic requirement of a Cronbach alpha is that there should be continuous variable. Most commonly, it is done for the Likert type of item. Can be done for other question having 2 responses, but that's the another way of doing it. Now coming to the dimensionality of the scale. So you people were also writing here like 2 domains versus 3 domains. So that if you already know that the scale is a multi-dimension, that means it is measuring more than one dimension. So in that context, what we do, generally variables are expressed as item and each item is grouped together to form a scale. Like PHQ 9, you will see that it measures one dimension. And yesterday also you have seen that GHQ and this quality of life BREF. So quality of life BREF was a multi-dimensional scale. And in case of a DAS, that is the depression anxiety score, that is again, it measures more than one dimension. So that is the multi-dimensional. So if the scale is, so one of the assumption of Cronbach alpha is that it takes or it assumes that the scale is unidimensional. That is one of the limitation of the Cronbach alpha. That's why we will see that we do Cronbach alpha twice. Right now, like before you do the exploratory factor analysis, principal component analysis, and confirmatory factor analysis, you do this Cronbach alpha to see the consistency. Then again, once you know that how many factor or how many latent variable, how many factor that latent variable has, you again apply that Cronbach alpha factor wise, means dimension wise. So if the scale is of multi-dimension, that means if you are doing the internal consistency of WHO quality of life BREF, and I say that it has got probably 4 domain, how many times you have to run this Cronbach alpha? Yes, please type in the chat box. 5. So very right. You will not apply that to once because you will apply it dimension wise. Again, that's why we say that you will have to perform more than one reliability analysis. In case of when the scale is unidimensional, then you have to perform only single reliability analysis and there will be one Cronbach alpha. So now coming to the properties of Cronbach alpha. So I said in the beginning, the reliability is not of scale. The reliability is of that scale in a particular population. I cannot say that the reliability of the STARS questionnaire is 0.8. I can say that reliability of that STARS questionnaire in my population is 0.8. So that population or that sample term is always necessary whenever we talk of reliability. That's why it keeps changing if you change the sample. So please remember, this reliability is of scale in a particular population. So again, I said that this value of alpha it is proportional to the number of items. Obviously, it is not as a linear, because it increases very rapidly. If you increase the number of items from 2 to 10, it increases if you increase the number of items from 10 to 30. But after 40, there is a plateau. So that it is a function of the length of questionnaire, and it will increase with the increased variability of each item. If there is an item which is very variable, then this will increase. So if your scale is having less, any scale if you apply, let's say statistical anxiety, and you are getting a less reliability, so you can add a few more items of that construct. It will increase the reliability. So, and if you have reliability, if you have any question which has which is having more variability, it will increase the reliability. So very high value of alpha, that is more than 0.9, it suggests that some items are redundant. That means you have got more than 2 or 3 items where you can remove one item also. So you can try seeing those items and can take a decision to maybe remove also. But many times we say that redundancy in a scale is a good thing. Generally, what we say that things should not be redundant. But in scale, to some extent, we like redundancy, because this shows that our measurement is having less of error. So this property of this Cronbach alpha is a property of response from specific sample that we have talked. So it is not a reliability of the item and not a reliability of the scale. So it is unique for each sample that we have discussed, and it varies from sample to sample. So it should be estimated each time the questionnaire is administered. So coming to the interpretation of Cronbach alpha, if the value of Cronbach alpha is more than equal to 0.9, we call it as a very good, excellent internal consistency. If it is 0.8 to 0.9, we say it is good. If it is 0.7 to 0.8, we say acceptable. So at least we say it should be more than equal to 0.7. Less than 0.7, it is not acceptable at all. So now there is something known as this standardized Cronbach alpha. This we don't get in JAMOVI. That's why I'm leaving it. There is a term which is known as the corrected item total correlation. This we'll see as an output in JAMOVI. Basically what it does, taking the example of that 5 x1 to x5. So what it does, it is the Pearson correlation between that specific item and the sum of the other items. That is the corrected item total correlation. So you can focus on this term, item total. That means that particular item, and if you remove that item, the sum of all other correlation. So that's the corrected item total correlation. So we say that if the items are all measuring the same construct, the correlation coefficient should be high, that we have discussed. So Pearson correlation coefficient, if it is, what should be the cutoff? So we say that it should be at least more than 0.3. If it is less than that, then you can consider removing that particular item from the analysis. And if the value of this corrected item total correlation is negative, then we'll have to reverse code that item. We'll see that. Now there is something known as the squared multiple correlation. What is that? So it is again the R square value, you all know, coefficient of determination. It is the R square value in the multiple regression with dependent variable as the specific item and predictors as the other item. So this R square is calculated like it takes one item as a dependent variable and rest all other items as an independent variable. Here we don't talk about construct. Remember, I will never talk about Y in case of reliability. Y we will talk only when we'll go to the validity. So that's why here in case of a squared multiple correlation. How this R square is getting calculated? Yes. Can anyone tell here? Dr. Priyanka? Okay, there is a question, items with more variability. I'll show you that also. Example. That means any items which has got, I'll show you that stars questionnaire. That you can check variability on this thing also. Objectively. We'll see that. So this squared multiple correlation in this dependent, yes, it can be, it is the square of coefficient, but in the linear regression, what it does, that particular item becomes the dependent variable and all other items become the independent variable. So generally, we do that to reduce the burden on respondent. We use a brief version of scale. But it is said that if reducing the version, if there is a compromise on validity and reliability, then you should not do that. So a lengthened scale, but with a good validity, is preferable than a poor measure which is brief. Now there is something known as the McDonald omega. So in JAMOVI, you will see that as output instead of Cronbach, along with Cronbach alpha, you have this McDonald omega also. So McDonald omega is a superior measure of the reliability because it removes all those limitations which this Cronbach alpha has. So this is an alternative of alpha because alpha works with the assumption that the scale should be unidimensional. I'm not discussing the other 2 points because we'll discuss that in factor loading when we'll do the factor analysis. So Cronbach alpha assumes that the scale is unidimensional. So if you know the dimension, then you have to apply those many Cronbach alpha. But if you are devising the scale for the first time, then if your scale is a multidimensional and if you have done only single reliability analysis, it will give you a lesser value of Cronbach alpha. McDonald omega is independent of this dimension. That's why it's a superior measure of reliability. Now there is something, we'll see that in output, there's a mean score. So what it tells about the item in the scale. So let's say if there's a scale of 12 items and all items are on a 5-point Likert scale. And that 5-point Likert scale, 1 is the disagree, 2 is disagree, neutral, agree and strongly agree. So if the mean scale score is 4.1, then I can say that most of the people are agreeing. So we can say that most of the response on this scale are on agree side. That's the interpretation of the mean score of scale. So validity is about the scale, but reliability is about the respondent. So we'll see now we'll see the how to do that. So this is the JAMOVI. I will how many of you have downloaded JAMOVI? I don't know how to ask this question. So yes, can you just type in the chat box? Either you can do hands up or something like that so that we can know how many of you have. So Kalpita has done that. Or maybe you can say who has not done it. Swati, you can do that now. Prashanta, Dhanya, Baljit. Satyanand, you can also do that. So 2 people I can see no till now. Priya is yes. So all of the people, they are yes. On Devjani on another device. Okay. Nipun Jot. So Nipun and all other people, we have shared the link. If not, you can go directly to the Google, type JAMOVI download for Windows or Mac, depending on what system you have, and download that solid version. I'll show you once for all those people, because otherwise in breakout room again you will have problem. Because then you will say that you don't have JAMOVI, because I want all of you to share your screen, practice that, then only you can learn. So maybe I can write. You go to Google and type download JAMOVI. And then if you click that, you can open this and you can see that there are two versions. There is a solid and there is a current. So you download this solid version and you will see that Windows version, download the solid version. Those of you who are working on Mac, you can download this Mac one. So you can have 5 minutes to download. Yes, you can take that time in the, so what you can do once I will demonstrate this, you people will go to the breakout room. So when the first participant is showing, you all can, rest of you can download it. Or we'll allot 5 minutes for this exercise. Okay, Dr. Devjani. Yeah, that current one is also okay. That is also okay, Dr. Sathya. Actually, current has got some latest feature, maybe that's why. But yes, no problem, even if you have done that. What is this? It's the ulta. So I'll go to this, how to import it. So I'll show you. You will have this activity in breakout room also. So go to this. And then you can click on open and you can show the path. So you can see browse. If you see browse and if I like, let me wear my specs. Then maybe I can go to that. And here you can download any type of, you can open. In data file, if you see, it imports all type of data like SAS, JASP, data, R, SPSS, Excel, CSV, everything. So you can select anything. Since I have already imported it, I can again do that. So this is my Excel sheet. Demo, this is for EFA. So let me see the reliability. So this is the reliability, demo reliability. I'll show you what this is. And then if you click on this open, then another JAMOVI will open. You can see there are two JAMOVI here and this is my data. So I'll explain you the data set first. So in the JAMOVI, if you see the options, so this is for those people who have never worked on JAMOVI, but again, the interface is very much similar to any other data analysis. The only positive point about JAMOVI is the user interface is very friendly, very friendly, even for people like all of us who are not a very high, I mean, you can say statistician, or maybe our background is not something, because most of us are from either the medical background or doing some PhD. So this is a very, you can say that command, we don't need to write the command. So it is the menu driven. So in this case, you can see there is an option of like these variables, and you can see there are 10 items. So can you see X1 to X10? And I'll show you the items. So these were the items which we have collected from the students. So there was a 51 items questionnaire stars, which we have shared with you people yesterday. And out of that, we have just took these 10 items. You can say this is modified only for the purpose of the workshop. We are not in a process of scale development. And we collected the real-time data. So like we have the data from the previous 3 workshops also, from all the participants. And the participants also helped us to gather more data from their friends. So these are, it is on a 5-point Likert scale. So the first statement is like, do you have stress in doing this activity? Like making an objective decision based on empirical data, and it is highly disagree to highly agree. Then do you have stress in reading a journal article that includes some statistical analysis? So do you have stress in asking one of the lecturers for help in understanding the statistical analysis section of the article. So I cannot interpret the meaning of a table in a journal article, agree or disagree, maybe various points on Likert scale, and then trying to decide which analysis is appropriate for my project. Then again, this question, like I have not done maths for a long time. I know I will have problems getting the statistics. I don't have enough brain to get through statistics. I wish statistics requirement should be removed from my academic program. I'm never going to use statistics, so why should I have to take it? I'm too slow in my thinking to get through statistics. So these are the 10 items which we have just randomly picked for workshop purpose to have a real-time data. And then you can see these are the items. So if I go to the variables, they are the x1 to x10 variable. So variable, you can like see, if I double click this, you can see the value. It should be like continuous, and you will see that it is the integer. So together, when you import the data from the Excel, you should check these things. So I'll select all the variable, because if you see the measure type, you should change it from the ordinal, nominal to continuous. So I've changed it to continuous because I'm assuming that this is a scale variable. The data type could be decimal, text, or integer, but I'm making it as integer. And then I can select all the item together. So X2, because I want all of them to do it. So you can select all the variable, and then you can change these. So I have got, you can see all the variables, and then I can change their measure to the continuous. And again, but again, you need to uncheck this. So slight change in the this you might need to do. And then I'll go to this data. So this is the data view. If you click like this, you can see this is the gender. This is the X1 to X2 item, X1 to X10. And those are the questions which you have seen. And we have taken the response over that. So are you clear on the data set, on which type of data set we are going to perform the analysis? And we have shared the same data set to you people, so that you people can also practice in the breakout room. So I'm not going to show you the other functions. Like if you go to analysis, you can see exploration, that is the descriptive, t-test, ANOVA, regression, and all those frequency, that is the chi-square, those things are there. In the purpose of this workshop, we'll focus on this stuff, factor. And most of the time, we'll be using this. So the basic way, once you install this, I think you will get all these. You can see the other module here. So don't get confused, because that we generally download from here. So okay, you can see a plus sign here. If you click that plus sign, and if you go to JAMOVI library, then it will show you what are the package which are installed and what are the package which are available. So if you want to perform some analysis, you can click that install and it will be installed. So I'll say, like I can say that this is a very powerful tool rather, because this works on R. But R, those of you who have done it earlier, you need to write a lot of commands over R. That's why even I learned at one point of time, but then we tend to forget because we are not into continuously into practice. So this JAMOVI is exactly that menu-driven command of R. So all the languages which are here written, that is R. And the beauty is that it is a freely available software. Other software like SPSS and maybe the Stata, you need to pay for it. And if you use a pirated version, you will not have a full version, all the features. And you cannot write it also very, this thing that you have used SPSS, because then there is an issue of piracy. So that issue is there, but this JAMOVI you can use. And for factor analysis, one more advantage of this JAMOVI, that SPSS, if you buy that SPSS, factor analysis option is not there. For that, you need to buy another AMOS. So over that, you can perform the factor analysis. But in JAMOVI, even the structural equation model, which we are not discussing this time, it has got very beautiful feature. And all that path diagram, you will see, it's very, very, it's very powerful. I like it very much. So you will also start liking it once you find the ease of doing it. So yes, then I can go over this factor. So you click on this factor. Now you can see there are many options. In scale analysis, there is a reliability. And under data reduction, we have got principal component, exploratory factor analysis, and confirmatory factor analysis. So these three we are not going to learn today. We'll do it tomorrow and day after tomorrow. Today we'll learn this reliability analysis. So I click that. So you can see that in this JAMOVI, this is the same, on the same view, you have got the variable view and there is an output view also. So this, because other software, you will see that output view is other different. And this is again a dynamic, means if you move the variable here, then the result will appear here. So what do? I will start moving all these items. So I am considering that all these 10 items are under a single dimension. So I am considering my scale right now to be a unidimensional scale. That's why I will move all these items from X1 to X10. You can press Shift button and then, I don't know why it is, just a second. And shift all these variables to the item box. So now you can see that there is on towards the left side, it is the scale statistics. And towards the right side, it is the item statistics. So what do you mean by both these two things? Can someone say what is a scale statistics? So basically, scale statistics is the summary of all items. So a scale here in this case is the statistical anxiety measuring scale, which is having all the 10 items. So this will give you the overall scale statistic. And this item statistics it will give you the individual item statistics for all the 10 items. Okay, variance, yes. Actually, basically, it is taking variance into account. You are right, Dr. Debjani. In the background, actually, it is doing it through the measurement of variance. But I'm not going into those statistical concepts. But yes, you are right. It is basically the variance. So this you can see that I will click that. I talked about McDonald omega, that this is a superior measure of Cronbach alpha. In case the scale is a multidimensional, unidimensional, this two value will be same. I will click this mean standard deviation and then you can see the result. So you can see that scale is having a mean of 2.42, standard deviation of 0.72, and the value of Cronbach alpha and McDonald omega is 0.81. So is this scale for this particular sample is reliable? If I see the value of Cronbach alpha. So all of you agree? Okay. What do you mean by this 2.42? So I'll show you that probably. If I show you this responses. So if this is 1, 2, then this is 2. Yes. So majority disagree. Or maybe it is in between agree and then neutral. Yeah, but agree. So that we mean by the interpretation of the. Now coming to the item statistics. Yes, Dr. Prashant, Supriya. Dr. Bashar, all of you are right. So now I will click the item statistics. So I have clicked the item statistics. So in item statistics, you will read what is written here. Supriya, can you read this? What is written here?
Yes, ma'am. Cronbach's alpha if item is dropped.
Okay. So again, this is the Cronbach alpha of that scale. But when you drop that item, what will be the Cronbach alpha? Similarly, the McDonald omega, if that item is dropped, and then mean of that item, standard deviation, and remember we talked about this item rest correlation. That means the correlation with that particular item and the rest of all other items. So we'll spend few more minutes describing this table. So this is the mean of individual item. That means, and you can see that which has got the highest mean in this case. Can anyone say? Highest mean is for which item? Scale? I mean, X1, X5. Yes, X5 because it is 3.07. So if you go and see your X5, so your X5 was this. Trying to decide which analysis is appropriate for my research project. So most of them have responded that the score is towards the higher side. That means there is some sort of, maybe it is more than the mean score of the scale. Okay. And then this is the standard deviation. Yes. And then you can also write the least score. So least mean score was for which item? Yes. So I can see 2 point. Which one is the let me see the chat box. X9. Yes. So X9 is having 2.03. Agree. So now focusing on this, you have to now focus on this particular column, which is the item rest correlation. So what was the value of item rest correlation which we fixed? So we have to see if the value should be more than 0.3, because that will say that this item is also getting affected by the underlying construct. So till now, I have not talked about anything about the construct. Remember, I'm only talking about items, items, and items. So this you can see which are the item which is having a item rest correlation of maybe less than 0.3. Yes. Let me see the chart. So Dr. Vikram is writing X5. Is this the same? Okay, so role of means, Dr. Devjani is requesting for this role of mean. So should I explain this once again? So I'll explain this. So you want the mean of item wise or mean of overall scale, Dr. Devjani?
Overall scale?
Okay, so if the mean of overall scale is 2.42, then I can say I will go to that item and I'll see that which item, what was the response of 2. So maybe if I have taken this as 0, 1, 2, or maybe 1, 2, 3, 4, and 5. This is 5 item Likert scale, 5 point. So 2.42 means that majority of the people, they are saying the score is between this disagree and the neutral, 2.42. It is towards the, if you take it like less than 2.5, it is towards the disagree. That they are largely saying that they are not agreeing with all these. That means right now I am not coming into whether they have the statistical anxiety or not. But majority of the people, they are saying that they don't agree with this. That means
I got it.
Okay. Okay. Thank you. Yes, so we were discussing regarding this, that this is the X5 is having a item rest correlation, which is 0.26. Again, if you see this is again very borderline, 0.30. So this should be at least more than 0.3. And in the context of this, you will see that if you drop this item, the overall omega will improve. Omega or alpha, whatever you take. So in both these two cases, you will see that this gives you what will be the omega or Cronbach alpha of this scale if you drop this item. So what it will be? There is an increase. Although that increase is only very slight. From 0.81, it has increased to 0.82. There's not of much increase. But again, you can see, although this is a very small, just for demonstration. So if the scale is very large, like 50 items, and then if you are trying to aim for a reduction, how mean is high and correlation is 2.6. Both are different things. Mean is high, suggesting some other interpretation. Correlation, it's 0.26. That means it is not getting affected by the hidden construct or by the unobserved construct as good as the other items. That's the meaning of item rest correlation. Because the measurement model says that all these should be highly correlated with each other. So if the highly correlated means at least it should be more than 0.3. That's why we say it should be highly correlated. So that's why that interpretation of mean is different, which you have seen here, like 3.07. That means people are responding it to be like 3.07, but the item rest correlation. So those are two separate things, right? Those are not same. That's why interpretation is also different. And if you remove that, delete that item, then your McDonald omega or Cronbach alpha, whatever you take, that will be improved. Although it will improved only by 0.01, but it will improve. So that's the overall interpretation of this table. So maybe only such slight increase, then we don't drop item, because you have selected these items also, and then you can probably check on some other sample like that, but report. Ultimately, we have to report this 0.81. We don't go for these minute reporting if we are doing the only reporting the reliability. So we say that the value of that Cronbach alpha. So no, net increase 0.78. So overall is 0.81. So you see from this point. So from 0.81, it is increasing to 0.82. It is not from 0.78. This 0.78 is what? This 0.78 is not the overall omega. It is saying that if you drop this item, so this says that you cannot drop this item. X1 is very important because it is leading to decrease. So you cannot drop this item. Okay. So all of these are saying that you cannot drop any, because after dropping that, the scale reliability is decreasing. Only these two, that is the X5 and X9, it is saying that if you drop, the reliability will increase. But that increase is very minor. 0.01 is not increase at all. So you can leave it as such, because overall reliability of scale is also good. It is 0.8. Minimum we keep 0.7. So it is more than that. So you can say that in your population, the scale is reliable. So have you understood up till this point? Okay, if yes, then I'll show you just one function and then we'll go to the breakout room. So there is something known as the correlation heat map. So Dr. Shraddha, what should I repeat? If you can guide me particular, or should I repeat everything since beginning? Let me see. Repeat the last two columns. Okay. Last two columns. Okay. So yes, should I ask some other person to repeat the same, or maybe? Okay, I'll do that. Cronbach alpha. Okay, Cronbach alpha or McDonald omega, both are same. So actually, like Supriya read initially, I asked her to read. you focus on this. What is written here? No. Don't talk about validity. My dear, we are not talking of validity till now. Okay. Yes, data importing is possible, Dr. Devjani. I'll again once again I'll show that. So we have not talked of construct. We are only talking reliability. So please forget validity for now. Only think of reliability. Only think of reliability. Then otherwise you will be confused because it will be all mix of, because one participant wrote content reliability. No. Content is always in context of validity. It was a content sampling. So reliability, remember, 4 types. There's an inter-rater, kappa, test retest reliability, which we have shown you, temporal reliability, split half reliability. I think I have not talked about split half reliability now. Okay, I'll talk about split half reliability also. And then there's the internal consistency. Okay. So first you understand this, then I'll show you the split half reliability also. What is a split half reliability? So let me first explain this. So what is written here? If item dropped, that means if I remove this item from this scale, what will happen to the McDonald omega or Cronbach alpha? So basically, if by dropping that item or deleting that item from that scale, if your overall reliability is increasing, that means it is good. But again, by how much? So here it is not a much increase. Many times what happens by deleting one item, if your reliability of your scale is 0.6, then that means it is not acceptable. And then it suddenly becomes 0.7, that means acceptable. Then you can try doing that. But here already your reliability is good. It is 0.8. And by dropping that item also, it is adding to very insignificant 0.01, like from 8 point. So overall, what is the overall reliability of your scale? It is 0.81. Do you agree with this, Dr. Shraddha? What is the overall reliability? Is 0.81. If I drop this item, the reliability will be, that means my reliability will be how much jump? Yes, it is up to you, actually, Dr. Vikram. So let me explain this, then I'll come to your question. So like 0.78. So if you are dropping this item, your McDonald omega or Cronbach alpha, it is decreasing. That means your reliability is decreasing. That means you should not drop this item. So all other, if you see the value, if you remove that particular item, your Cronbach alpha is getting less. That means you will not remove these items. Only 2 items, that means X5 and the X9, which is leading to that to McDonald omega. In case of alpha, you will see that it is not even causing that. It is same 0.81. Only this 0.82, this item X5. If you see this, only if you remove this, your overall reliability of your scale will increase only very fractional, that is point. You can try this also. What you can do, you move this back. So it is X5. So what I do, I will move this X5 back to this window. And see, now your Cronbach alpha from 8.1, it has again come to 0.82. So you can see, and now again you see, there is no improvement. Whether you remove one item or not, it will be 0.82. Okay. So that is the overall interpretation of the Cronbach alpha and McDonald omega. Now there was a question of Dr. Vikram, by how much? So it depends on the length of your questionnaire. If your length is already 8 item or 9 item and you are gaining a very less of overall, then there is no point removing that item. If your length of the questionnaire is very high, maybe 50, 55, then you can try removing 2 or 3 items. Okay. Otherwise, for a very minor, because overall also the reliability is good. So we don't generally delete the item because it is not adding that much to our. But again, if you don't want, you can remove that. So that is up to you. But generally, we don't recommend. If there is an increase like that, I don't currently, I can't tell you that is there any objective way to decide that or not. But I think it's subjective. You can, and I have seen most of the reference textbook, they say that you should not do that unless and until it is leading, let's say maybe 1 or maybe 0.05 or something like that. But 0.01, 0.02, 0.03, there's not much gain if you delete that item. Okay. So I was telling you two things I have not discussed. One is the heat map. So maybe if you click that heat map, you can see that there is this will give you the correlation. So you can see this X4 has got a negative correlation. This X2 also, slightly pink is there. Others are green. So this is the just one diagrammatic representation. Again, I wanted to talk about the split half reliability. What is a split half reliability? I did not discuss, I forgot. So what do you understand by split half reliability? So basically, like if there are 10 questions. So if I say that the first half of the question, the score are highly correlated with the second half, then I may do this split half reliability. Okay, in that case, what you can do, you can select the questions alternatively. So there are 2-3 ways of doing split half. You can select first 5 and the next 5 and then see. But that will have a bias because you can see that if the question is long, generally we get tired at the end of responding. So that will create a bias. So what you should do, either you can choose like alternate, all odd and even like this. Then you can do that. But we are not telling you in this session. Basically, we do the Cronbach alpha and the McDonald omega. So if all of you have got this, you should go to the breakout room. Now there are few instructions of that breakout room. So breakout room 1, 2, and 3. So we have created today the breakout room 4 participants per group.
If possible, hello.
Yes, Dr. Devjani.
Possible, just the data import, a couple of minutes, I think so. I missed that part.
Okay.
Sorry, I missed that part actually.
So click this, go to open and show the path. Browse. And you can see that there is having 2 sheets. So you have to import this demo, that Excel sheet. You can either open this demo reliability directly, but if you want to learn, then you can open this in demo reliability. So you click this and then you open. Okay.
Right. And it accepts Excel. We do not need to make any modification.
Yeah, you can see all the data, Excel, SPSS.
Excel is there. Right. Okay. Thank you so much.
So in Excel, just a second. So maybe that mentor can do. Look, let me open. Okay, so I'll show you Excel sheet also, because if you open this Excel, there are 2 sheets. So first is the pilot data of reliability, where you will see that all these name of the items are there. And then there is a pilot data on reliability without label. So whatever will be the active sheet, that will be imported on JAMOVI. So I ask, please open this Excel first and make this as an active sheet. Otherwise, the data which will be uploaded, that will be like with this item, name. So that will be very long, and maybe that result which you will see. But again, up to you. If you wish to, you can also do that. I don't know. Whatever you like. So that I have shown you. So I was reading the rule for breakout room.